Hello class, good morning. Yes, am I audible? Class, hello.
Good morning, ma'am.
Okay. Very good morning. So let's start the class and the previous discussion was for asymptotic notation, big O notation and few examples. We have seen where you have got the idea how to prove if any expression is given, then can we write down that in terms of big O notation and how to write. For example, if n square plus n can be written as order of n square and can be written order of n cube as well with the different values of constant and n0. I hope you are getting what I'm saying. Yes. Ayush, Aviral, Deepak, Punera, Hariom, Gupta. Are you getting what I'm saying? Okay, so after that, we are not going to repeat the previous one. Let's proceed towards the next part further. Another asymptotic notation, omega, where you will find it similar in terms of representation with the change in one condition only. Okay, with the change in one condition only. There you are having the condition that your function must be less than equal to c dot gn, but here you will find the condition reverse. Your function fn is greater than equal to c dot gn. Rest of the things are same. How to find out the c and what is gn, that all is same. So you can write down that the function you are using in terms of omega notation. So Fn is of order this omega Gn. If there exists constant C greater than 0 and a particular minimum value of n which is represented by n0 as greater than 0 in such a way so that this condition is true, that is your function is greater than equal to this one. What does it mean? If your value of the function is greater than, certainly this is going to represent the lower limit because the value is always greater or equal, always greater. So lower bound, this is omega notation is putting the lower bounds on the value, which gives the idea that the function is having the lower bound c dot gn. Gn is the standard function. Okay, rest all will remain same, the discussion which we have made earlier. So if you go for looking that what this under root n can be represented to in terms of omega, you will find it this omega log n. There this particular thing actually needs the value of that log n table, but here you can just accept it and have a memorization of some standard functions and their relativity. Like you have seen previously many graphs where you must have seen this under root n and log n plotted. Yes, it is here under root n and this is your log n. So it remains always lower. So some standard functions you can memorize also in terms of these graphs. Okay. We are here for the omega, right? And it is coming up with these values c equal to 1 while n0 is going for a very high value. Okay, means the thing is if your values are, let's say you are representing like this 2 4 8 16, so it's let's say you are putting it here 16. Now in this case at this point only, let's say for this one There only you are finding your Fn is greater than equal to this Fn. Fn is greater than equal to this is your C dot Gn. C dot Gn. Before this, you may find the various values of the function, maybe for Fn this one and for Gn something like this. There can be any possibility, Fn greater or C dot Gn greater, but after this point, in this particular case, you will find for C equal to 1 and this, okay. So in this way, you can have a learning of this concept that omega dot Gn is the set of all functions with a larger or same order of growth as Gn, because greater or equal, right? Now, if you go for the theta notation, for the theta, actually I have made that particular representation by cutting down many things. For the theta notation, you will find the combination of both the conditions. I'm looking if I can find it here in this one. Okay, it's not here, no problem. Let's go without that kind of representation. It's a mathematical form only. See here, this scroll also helps to get know about. As we discussed, theta is the tide bound, and tide bound, this slide we have already discussed. So some kind of rearrangements I have made earlier actually. Okay, so this example I will discuss after a while. Before I would like to show you this particular one. Okay, so theta is the tide bound where you represent the particular function of order theta. For Gn, there exists a positive constant C1, C2. You are in need to then for different constants, because in case of big O notation, you have a constant C. In case of omega also, you have a constant C. But if you are having the both the bounds putting together, then these C and C them separately will be for case of theta, like with some another, otherwise the values will mix. See, two constants, one will be working for big O, other will be omega. And what that is, you know, the function is less than equal to, in case of big O notation, this C2. Okay, that's not a problem. Here it is coming up with C2 and this is C1. That can be different also, no problem, but let us match the expression with this one. So Fn is less than equal to, so this is for the upper bound, that is for big O notation, this much part. It gets joined with the omega also, where you are saying this Fn is greater than equal to C1 dot Gn. So certainly there will be two different constant, and this is representing to the theta notation. Okay. So it's a kind of mathematical part. If we talk about the scope of this subject, this algorithm, then we are majorly concerned with the some standard form uses for representing the complexity, where the big O represents the specific use of upper bound, because upper bound is a more concern because of worst case where it doesn't go beyond that, so is a limit, upper limit. But you should know this omega and theta also. Okay, so here it was that. So this is for the purpose you don't feel a difficult one to refer the book when it is written in such a way. It is same. You can say that Fn is of theta Gn, and what do you say, that f of n is theta of Gn. In this way you can read it. If there exists the constant C1, C2 and n0, of course, okay, for certain a limit, that is after some limit, like in case of the example you have seen there 16 value was there, where I have drawn the graph also. So this is the same for theta. Okay, now it is written in terms of paragraph, but actually what it says that, you see, you will find a lot of matching with this omega capital O, big O also. Like you can say this particular function 3n plus 2 can be written as theta of n. because you are able to find out the C1 and C2 to show that this function is lesser than this C2 dot Gn and greater than this one. So it's all about finding the constant and n0. Why it is said? Because you are able to show that 3n plus 2 is greater than 3n for all the values when you have the value greater than equal to 2. So it's same like I have told you that tabular method, you can draw the table and then write down the values of n, and here you can have your own function. In this particular example, if you look for this first example, your fn is this one. This is the fn. Okay, so this 3n plus 2 is your function, and then you can write down here that c1 dot gn. What will be the gn here? In this particular example, you know very well, somehow you will be having it is of order n, because there is no other term of n. Okay, so you may go for c1 dot gn with different values of c1. Gn is your n. So you can easily show that for all these you will find that fn is this less than equal to n as well as greater than. In case when you have the n greater than equal to 2, but C1 is 3 and C2 is 4. So you can do these mathematical calculations to represent the proof of such a situation where Fn is representing the condition for less than equal to with some other constant C2, and here Fn greater than equal to with some other constant C1. So here it is all solved. Here you can just see actually the values are coming up to show this condition true or not. So you can work out over it with this example. Okay, here this is for up to here the one example is there, then for another one you have the 3n plus 3. So you can experiment, you can practice, not experiment, actually you have to go with pen and paper for looking that for different values of constants and n0 you are able to show the truthness of this condition. Here you have, so I'm leaving it for your practice, and you can come back for your queries if you will not be able to solve. Here the partial hints solutions are also given. Okay, you can work out over. If you have currently any query, you can ask. Okay, for example, this equation to prove that you can write down n square is of omega n. You know very well omega is representing the lower bound. Okay, so you may have a function with the a lower possibility of values in comparison to this, so omega n, but it is to be proved. Then in that case you have to be taking care of the particular constant and the n0, and with the help of that you can show the truthness of this, representing that n square is greater than equal to this c1 dot n. Okay, so try for this. Here as per the definings you will find it true for c equal to 1 and greater than equal to 0. So just writing this is not sufficient. I suggest you to show the calculations also, because the expression is not very big, it's only directly n square. Okay, then next question to get the idea for such type of the topic, whether the following statement is correct or wrong. Okay, you have to prove this also to tell for the correctness if you say it is correct, and for the wrong also if you say it is wrong. Only the condition is to be shown with numerical values, with the constant and with n0. Okay, so you can work out and then solve all these and then ask your queries if any, right? So this is about the theta notation, and omega, big O we have already done. Some more examples here, even the with solutions. So this all you will find, and you can see the process you are already aware with how to do it. You have to represent for the big O, so you are in the direction towards to show that this Fn will be having the value less than equal to C dot Gn. Some constant will be multiplied with 2 to the power n. Okay. So in this way, it is just guessed. Okay, let us take this equal to 2 and n05. Okay, so the reason behind for taking the table is that you get the fast idea by looking the values that what should you jump for. Maybe up to the 1 you are not finding, then 2 for n equal to 2 you are not finding, then for n equal to 3. So maybe directly you are jumping for the 5. You can do that. That's not a problem, because you are finding that there is no possibility to find out the condition true from 1 to 4 by looking the first two values, let us say. So you can do that. Okay, so in this way you can work out for such problems. Some more examples for you. Okay, like here. Okay, sequential search, this is about the loop, how many times a particular loop is running. If you have a single loop, now it is about actually if some partial code is given to you, how do you represent the directly complexity of that part. So in case of the sequential search, that is the linear search, you have a single loop, for loop, you go on searching. If it match with the particular element, then you say okay, return, and the process is done because of a single loop. So that is going to run for n number of times, so the complexity is of order n, right? If then else statement, then what will be the complexity? Now it's complete one. Then again you have to see maximum number of times the particular condition will run. That will help to find out the complexity. Now for this particular condition true, then this statement will execute. That is, at the most the condition will be true. The maximum time it will run will be fixed one time only, so the order of 1. Then after you have this loop, so we have to go for the maximum possibility. Okay, so maximum number of times it can run with, right? Now in this case you are finding here that a max of either this one or this one. Why it is represented? Maybe the condition is false, then it will not run. But even then you have taken this separately also. Okay, or you can say here max of this, always the max is, it is a constant time, it is a dependent one. You have to consider the variable in variable intrinsic variable order of n. So just avoiding the constant part, order of n. So in this case also you can directly consider in this way for this complete code also, that there is a single loop which is with the intrinsic variable, so the complexity is of order n. But in that way you have to explain in terms of statement somehow. So because it's a constant time, so can be ignored for this one. Maybe it will run, maybe it will not run, but whatever be the case, there is a constant time taken up for this part. So the complexity is of order n. Okay, so in this way you have to have the practice to find out the complexities. Okay, consecutive statements, how to find out the complexity for consecutive statements. These are independent loops. This is a loop and this is a loop. You know very well, you have to find out the total number of times the code statements will run, and for these loops part only, it will run for, there are three atomic conditions, you can say, not condition, statements, maybe that there are three statements to run, and here are the five statements to run. So total how many statements it will run for, how many times, n times, so written over here 3n. And these fixed five statements will run how many times, the loop will run n times, so 5n times. So whatever be the case, if you are representing in the theta notation, you can directly represent in this way. So in this way, sometimes you can represent by explaining in words directly also. You have to have the observation about the question, what the question is asking, whether it is asking for the explanation also or not. But I would suggest always to give the keynote for the logic you are using for representing the complexity. For example, here you will be telling for the first loop there will be 3 statements which will run for n times depending on the loop size. Loop is from 0 to less than n, so 3n times it will run and 5n times. So total step counts are your 8n, and that is of order n, so theta n is written. Now here I would like to mention directly the theta is used, no problem. If it is not asked that in which asymptotic notation you have to present, you can use either big O, either theta or omega. Okay, and directly without mentioning the constant, no problem, because some constant will come out and some n0 will come out, with the help of which you will be able to establish this theta, a big O and omega. Okay. So now nested loop, how to proceed for finding the complexity for the nested loops. Outer loop, within that 2 statements, there can be any number of, but for example in this case you can consider the 2, and within that you have the another loop within which you have the 3 statements. Okay, so in this case you should be knowing that this loop, for each value of k, for k equal to 0, let us say, for k equal to 0 fixed value of this one, this is going to run for n times. For k equal to 1, again this is going to run for n times. So this is the n times this is going to run. Actually, if you go very roughly without giving attention toward the specific values, then you can say this is going to run for n square times, or it is of order n square. Here it is written with 2 plus 3n. For a specific value of j, this will run for 2 specific number of times. So within this, it is mentioned that this is going to run for 3n times, and this is going to run for specific. So in combination of these two, it may be written by this way: 2 plus 3n. For a specific value of this is going to run for 2 times, and within inner loop statements like here, the 3 will depend upon the outer loop's number of times. Before that, this is going to run for n times. So 2 plus 3, and this is the way, in this way you can find out. And if you want to be very particular, just take the example for some value of n. Let us say you take the value of n2, and let's say you take the value, okay, it is n, always fix one. If it is here 2, then here also it is 2. Then you can easily calculate that how many times it will run. This expression will give you the right value. But as a normal way, for this particular loop, if you go with, this one, this particular loop is going to run how many times? This will run for 0, this will run for value 1, and this is going to run for 2 also. But the inner loop will run for 2 times, right? The value of n 0 times, for the value 0, for the value 1. So how many times this is going to run for? 2 times. Which one? Inner loop. This is for the inner loop. To try to understand the number of times the execution of this statement. But why the inner outer will run for 2? This concept I discussed before also. Because for the value n equal to 2, the condition will become false, but this will execute. This is important to know. Okay, so that's why the loops are set to run for n plus 1 times, okay, separately. And for each value of 0, this is again going to run for k equal to 0, k equal to 1. And for value 1 also, this is going to run for this 0 and 1. Okay, so in this way you can put the values here. If you put the values here, then you are going to find out 2 plus 3n. 3n, this is 6. 2 plus 6. Okay, just to be idea for a fixed value, but otherwise we are not interested for this. We are interested for the order, that is in terms of n function only. Okay, and here you have the value 2, So this is going to show this 16 times. 16 number of steps will execute. So you can work out and then later you can come back with your queries. But actually I don't want you to be, but some of you may be interested to for that. But my objective is here for the asymptotic notations to get the dominating term, leading term in the expression, and we know this is going to have a kind of multiplication of this with this. This is n times, this is n times, so n into n. Okay, so order is of n square. Okay, inner loop. Whenever you have a double loop, you can say it is of order n square. That's all. This is a fixed concept you may observe. Okay. Now in this case, when you have a recursion process, how to represent, then again you have to go for finding the total number of times the function will, the statements will execute. Okay, so just have a look on this slide. I'm not explaining it right now. You have the observations and later we can discuss. I will start with the bubble sort and the discussions over the logic so that you can have an assignment and the complexity of that assignment for the lab and the complexity discussion. This is the binary search. Binary search process is also clear to you how to get the complexity of it, that you can see, work out, and later we can have a more discussion. But you are needed to have the attention first. So there are many things. Insertion sort is also to be discussed. Okay, so we will go on picking up. Selection sort we have discussed. Now the logic we will not discuss, in terms of the complexity only. You can know the way how to get the complexity. Okay, understanding time complexity, the simple examples we have seen, and where we use the order of n square, order of log n, that is also clear to you. We have seen the tabular method, and now to be specific for, so there are many things written over here. For more explanation, if you have this code, again the simple code one, fix, there is only one statement, so the complexity is of order 1. Okay, some other easy examples for you. Linear search we have discussed, binary search method. So this all I will provide for your own working out and then coming back with your queries. Linear search we have discussed because there is only one loop, the complexity is coming up with that. Okay, so now I'm going to talk about the, this is the assignment related to the unit 1 that I will provide. I will upload this, I have shown you. Okay, so let me specific for the bubble sort and its complexity issue. There also, because we have already discussed that when there are the two loops, outer loop, inner loop, then the complexity is of order n square. Okay, so here, okay, let me give you the few seconds time. Please ask your query if
Ma'am, are you speaking? You are not audible.
Oh, I'm so sorry. Okay. Okay, so I was telling that bubble sort is not a new method for you. You all know about that you compare the elements in the pairs, and accordingly, if it is to be arranged in ascending order, you swap the elements. A smaller element is coming to this side and bigger element is coming to this side in case of 5 and 4 here. Okay, and go on swapping in this way. After the comparison process, you find out the element largest at the end. So it is at the final position, then rest data is here from this one to this one, and again you compare the elements in the pairs, and then you find the interchange operation, and what the situation is, you are going to get here the second largest element. So then 4 and 5. So in every phase you are finding the elements sorted at the end, and then at the next position, and maybe now then again you will find the sorted element at the last position, and in this way you complete the process. And you can write down the algorithm in this form also. This is for your better confidence. Sometime you find difficulty, then you can write down the algorithm with this way also, starting with the first element, index is 0, compare the current. Even you may not need, you may not mentioning the index there is okay, you may skip this also. Current element with the next of the array, if the current element is greater than the next element of the array, swap them. And here you can mention it is the case when you are going to arrange in the ascending order. Otherwise order is different, then the condition or interchange operation will be different. Okay, so it is for the ascending order when you find the current element is greater, because greater should go at the end, so interchange is required. If the current element is less than next element, then move to the next element and repeat the step 1 and 2 till the last element. So you may have some other way also of representation. This is the code where you find out that you compare the elements, and then just a minute, I have to make it smaller because you're not able to see it properly otherwise. Okay. Okay. So in case of the bubble sort, the code is written over here with the for the same logic representation which we have seen with the data set. Okay, declaring the array using the variable for the size, then because this is the maximum size mentioned, you may have the elements less than 100. So n is at the liberty of the user programmer that how much data is to be. Maybe if the data is to be more than 100, then you will have the size more. Yes.
मैम प्लीज मेक एवरीवन अटेंडी
Hello.
बार बार कोई हेलो
Yes.
मैम सबको अटेंडी बना दो बार बार रिमूव कर रहा है सुबह से यही कर रहे हैं तब से कि बार बार
Actually, what happened, let me tell you, I wanted to schedule the classes, but there was some technical problem. Old previous batches की जो classes के साथ match कर रहा तो ये schedule नहीं हो पाया था. I have made this request already so that others can be attending only. ये schedule वैसे हो नहीं पाया है ना, ये तो calendar के through नहीं है class. Today I will work out again for that. But if you are able to identify who is doing that, please write mail for me, or you can tell me the name right now even. This is not good. Whoever is doing this activity. Yes, who are you speaking? Hello? Okay. So here for declaration part, then reading the value of n. Okay. So it's only that part. Enter the elements. So for the size and for the data. Is it okay? Now here exactly all data is going into the array. Array data is going to be created with this loop. Okay, it's quite isolated one. you know the number of times it will run of order n. मैं direct बात करती हूँ of order n की separately, we can do that. Okay, and here if you see this block of the code, you are finding here the two overlapped loops. This is the outer loop and this is the inner loop. Whatever be the case, because of the two loops are there, then this block is going to run in terms of n order n square, in terms of n order of n square. So the complexity of this part is of order n, the complexity of this part is of order n square. And now if you see here, this is simply going to print the values and one loop is there. So in terms of n, again the complexity of this part would also be n. Okay, I don't think the logic of this is required to be discussed. You please give all time. This is the swap operation performed depending on this condition. Okay, because the elements are to be compared in pairs, so you are in need to have the two loops. Okay, inner one and the outer one. Right, now if you see the overall part of this one, the complexity of this is of order n, because you have to find out the leading term. And here I'm not writing even the expression. You can separately write down the complexity of different blocks and then in total come up with the selection of the highest order one and discarding these, because you have to go with the worst case. Maximum time will be controlled by this loop only, right? So order of n is square. This way, the point of discussion here is that how to improve the complexity of this bubble sort general form. This is the algo where we compare the elements in pairs, is a general form of the bubble sort algorithm, which gives the complexity of order n square. Now the question is, when the topic of discussion is the subject algorithm complexity, not only finding the complexity of the given code, we should be able to have the idea how to improve that complexity. Okay, so how to improve the general form of the bubble sort algorithm so that it gives the best case complexity for already sorted data. If the data is already sorted and it has somehow come is noticed that the data is already sorted, then why to go for comparing the elements for n square times in pairs every time? When you have the elements already known, that data is already sorted, then somehow at the initial phase, जब आप यहाँ compare करते हैं loops में, यहाँ here, if you find always there is no swap operation used, then it is clear data is already sorted. Then it should not come up with this loop's next value of the variable and coming to this activity again. Like you have the phase 1, phase 2, phase 3. Here, if you remember, I told you, this is the phase 1 told, shown, and the last element is the sorted one. The rest of the data, this is again to be sorted, and where you will go on comparing the numbers in pairs and interchange operation. But if in the first phase it is shown कि यहाँ कुछ interchange operation हुआ ही नहीं है, then what does it mean? It means the data is already sorted. So we have not to go for this activity again to compare and that, because this is the thing which is increasing the complexity from order n to n square. So somehow we may have a variable indication towards, if no interswap operation is taking place, then avoid the next repetition of the phase 2. Phase 2 that is going to happen for this part. Okay, so that kind of logic is to be done. So it is possible to modify the bubble sort to keep track of number of swaps it performs. If an array is already sorted in order, then bubble sort makes no swaps, and we can have a variable to check for this. If swap is 0, okay, then come out from the loop after the one pass only. And if the one pass is there, then the double loop is working like a single loop. And single loop order is, in terms of the complexity, you will say of order n. So instead of order n square, you have come up with the complexity of order n by avoiding the extra comparisons. Okay, So that is possible, and the logic is here shown in this. You have used a variable flag. If you will be finally coming up with the value without any change in this loop is going, flag is set to 0. If there will be the swap operations, it will come up within this loop. If it is not coming to within this, then flag will remain as it is. It is initially given as 1. Okay, so if flag is 1, already sorted. Okay, and automatically the other comparisons will be avoided, and you will be coming up with the complexity of order n. How the complexity of order n will be coming up? Are you clear? समझ आ रही है आपको बात?
Yes, ma'am.
Okay, so this is the point of discussion in terms of the subject for the bubble sort. Logic is clear to you. Emphasis towards how to improve that. So we have the techniques which we can use, like the variable flag is used to find out whether the swap operation took place or not. If not, it is obvious. So in that way, for the bubble sort, you have this lab activity which you will do in the lab. Normally, just implement the bubble sort, and then the next variety of the question is this one. Improve the general form of the bubble sort algorithm so that it gives the best case. The best case complexity हो गया ना, minimum time will be reduced and will be minimum 1. इससे ज़्यादा कम तो नहीं हो सकता. So best case. So you have converted the average case. In this case, you have the complexity average case, and average case is here like a worst case, क्योंकि इससे ज़्यादा तो कुछ होगा ही नहीं. Average and the worst is same in case of the bubble sort. So check the time of execution. This is the next activity which I told for your lab. Okay, code blocks automatically gives the time of execution. Okay, so you can see that, and take the case for sorting data in ascending order, and given data is also in ascending order. So you have to test also. Okay, for the best case. Initially आप data लेंगे mixed type का. Okay, and see the time, and for the same size of the data you will take the ascending order. So the same code will work for both the cases. You will see the change in the time. So do this activity for your bubble sort. Okay, yes, if you have any query, please ask. I'm downloading the attendance. Okay, so today's discussion was related to give you the capability to find out the complexity for given partial code, and to give you the capability to prove the expressions representation in the form of asymptotic notation, whether it is big O, theta or omega. How to prove them? By finding the particular constant and the minimum value of n, which we represent with n0. So such type of the things you will see in your assignment also, as we will complete this all. We have today is your last lecture for this week. Yes. Okay, so whatever we have completed, I will create an assignment for you, right? Okay.
Yes, ma'am.
Okay. Yeah, one thing I want to know, in this week, when can we have a lecture for your class to cover the yesterday's one? In that way, we will be able to complete your unit 1. I have to discuss the insertion sort in terms of complexity and count sort also. I will upload the PPTs for these two, insertion sort and count sort. Count sort is a linear sorting method. So can you tell me your whole class is available on which day, which time? Yes, class. Can we keep it on Saturday? Yes.
No, ma'am. No, ma'am. No, ma'am.
Why?
No,
Saturday you are
ma'am.
busy. Hmm?
मैम पहले से बहुत सारी क्लासेस है मैम सैटरडे को.
Yes, ma'am.
मैम
Okay.
सैटरडे को सारा क्लासेस बुक है.
So let's do one thing. I will upload the count sort and the insertion sort. You all will study and then we will try to accommodate the discussion in the next lecture and finish that early so that we can proceed further. Okay, we can do that because these are not very new things for you. But even then, don't hesitate to ask any kind of query, whether it is a fundamental discussion about the topics, insertion, bubble selection. Count must be new for you. You may not have studied count sort. So then we can cover in that manner, but anytime we can have the extra class to cover the previous one. Okay, I will make this query. Please, I will see your timetable also. If there will be a possibility, we will do that. Okay. Okay.
Excuse me, ma'am.
Yes.
Ma'am, could you just add one student in the team? He has just registered yet.
What's the name?
Asif Sheikh.
मुझे SAP ID बताएं.
14
13307. तो ये अभी रजिस्टर हुआ है और आपका
Yes,
ये
ma'am.
इन सेक्शन में है. ये पृथु बंसल भी आप ही लोगों ने नाम बताया था. कार्तिकेय भी आप ही की एन सेक्शन से है. एनीवन इज हियर हु टोल्ड मी द पृथु नेम? पृथु बंसल एंड कार्तिकेय. Okay, no problem. I will check. Okay, fine.